Okay, good morning. Today the session will be naming on to that faults. So in the earlier session we know about to that secondary structures, namely in the fold we already discussed. So what is the fold, how many types of folds is there. But in this session we know about to that fault. So generally any civil engineer they can understand of the secondary structures naming of to that fault. So why the importance of faults in the civil engineering constructions. Faults are unfavorable or unsuitable locations for due to construction. So why? Because of due to faulting. So maybe in the future scenario, so either is a construction of the dam, either it is a reservoir or any other civil engineering constructions, it may be collapsed due to faulting. So we'll see to that what is the general definition of the fault. So this is the definition of the fault. So displacement of rock strata we call it as a fault. So any rock masses to displace to that one place to either displace will be the downward, either it will be upward. So for example, if you see this particular image, so this is the fault line. So when the rock strata, this is the actual bed, the bed will be displaced with the downward movement, it will be called it as a fault. So if you see into that fault terminology, so we call it as this particular positions. So this is that footwall, we call it as in the, so this is the footwall. So if you see, so this particular position we call it as footwall. So this is we call it as a hanging wall. So when you see into that, so both planes, for example, if the one particular place displaced in the downward with respect to footwall, it will be called as a normal fault. We will discuss to that. So we generally know about the terminology of fault. So this is a footwall, this is the hanging wall. When displaced place in the vertical motions, we call it as thrown. So when you call it as a thrown, when the rock strata is displaced, how much areas will be displaced in the vertical position, so we call it as a thrown. When horizontal movement, we call it as a heave. That inclination of the bed, we call it as height. So if you seen into that this particular image, so some inclinations will be identified. So how much angle is there in the particular fault, we call it as a height. When the vertical displacement of rock strata, we call it as a thrown. When horizontal displacement of rock strata, we call it as a heave. So this is the background position, we call it as a footwall. This is the hanging wall. So this is the general terminology of faults. So faults are any fractured zones or a displacement of rock strata, we call it as fault. So whether it is the fault will the minor positions, we call it as creep, and the fault will be majorly escalated to that. So later on it will be developed on earthquakes. So types of faults based off relatively movement of the fault and based on that strike and dip directions. So the faults are differentiated different types. So these are we call it as a normal fault. So in that particular normal fault, in the relatively downward or relatively upward, we call it as a host or graben. So based on that strike direction and dip directions, we call it as the strike slip fault and dip slip fault or oblique fault. So these are the different types of faults. So while seeing that any type of rock masses. So now coming to that normal fault. So we already So if you see in this particular image, so this is the bed will be occurring of due to faulting. So this is about to that foot vault. We already known to that general terminology wise. So this is the hanging wall. The hanging wall moves relatively downward side with respect to foot wall. We call it as a normal fault. So the hanging wall downward movement will be observed in the particular rock masses. We call it as a normal fault. In the similar scenario, so this is the foot wall, this is the foot wall, this is the hanging wall. The foot wall movement will be relatively upward. We call it as a reverse fault. So normal fault and reverse fault will be both will be vice versa. And when the foot wall with respect to hanging wall, foot wall will be downward upward side. If we call it as a reverse fault, the hanging wall relatively downwards, we call it as a normal fault. And graben or host. So if you seen in this particular image, so two normal faults, if you seen in this particular image, two normal faults, so the one bed will be relatively downward, it will be formed as like a graben like structure. So the simple example of graben like structure, if you seen in that, so most of the coal deposits will be occurring in that graben like formations only. So in that our nearest places, we call it as a Khammam and Jangareddy, in the surrounding areas will be accumulation of coal deposits. So those will be graben like structures. So graben like structures means when the two normal faults, one normal fault will be relatively downward movement, it will be later on they will be formed as graben. So this is about graben like structures. In the similar scenario, two normal faults, one normal fault will be relatively upward direction, so it will be formed as host. So these are the based on the relatively movement of either foot wall, either hanging wall, it will be formed as to that graben and host. So now coming to that strike slip fault and oblique fault. So based on the strike and dip direction, so the faults will be developed. So due to lateral movement of the rock strata, either left side lateral movement, so the lateral movement of rock strata, so either left side lateral movement, either right side lateral movement, it will be the faulting will be developed along the strike direction. So along the strike direction, we call it as a strike slip fault. So strike slip fault another name is that tear fault or a transform fault. So these are the another name of strike slip fault. Strike slip fault means either left lateral or a right lateral. The movement will be occurring to that due to the faulting. So the displacement will be occurring to that along the strike plane. It will be called as a strike slip fault. Not oblique fault. So we know about to that strike and dip. So strike means the strike is a measure for the direction, the intersection between the horizontal plane and bedding plane. We call it as a strike. So always perpendicular positions will be occur. We call it as a dip. So if you see in that oblique fault, so this is the strike of the bed. So this is the dip of the bed. The movement will be occurring in that both places. So along the strike direction, along the dip direction, we have to identify it. So this we call it as a oblique fault or diagonal fault. So these are the based on that. These faults are developed based on that strike and dip directions. And parallel faults and step faults. So parallel faults means if you identify to that, so for example we consider as this is the rock masses, the beds are developed so parallel faults means same strike and same dip direction the bed will be movement, so we call it as a parallel faults. So if you seen into that, this particular bed along the strike direction, along the depth directions, they will be followed. So these will be called as parallel faults. So now coming to that step faults. So step faults are formed as along the dip direction. So it will be identified in the rock masses along the step directions only. So this is about step faults. So step faults are formed as based on to that dip direction. So parallel faults are formed as, so both are direction, either will be movement will be downward, the strike and dip directions, it will be called as a parallel faults. So along with the dip directions only, so we call it as the step faults. So these are the faults will be developing onto that different types of rock masses. And engineering considerations of faults. So generally we mean about the fault, this is unfavorable or unsuitable. So for example, as a civil engineer, we are working into the different types of fault zones. So while the working of the fault zones, which type of structures will be suitability? Why? Because if the faulting is available in the particular locations, if you constructed any type of bigger constructions, maybe it will be lose of in the future scenario. So either we consider to that, so whether it is a construction of any type of civil engineering constructions, either reservoir, either it will be dam or any bigger constructions. So before constructing, we are suitability of nature of the rock type, we are able to find out to that initial stage, so they will be proper on in the future scenario. So those type of problems will be escalate to that. So this is about the engineering considerations of fault. So when the faulting have due to the shearing and crushing, so definitely due to the shearing and crushing, the material will be weakened to that. So when the material will be weakened, so definitely in the future scenario, the fault will be occurring to that. So maybe due to the faulting, the place will be displaced to that either downward, either upward. So due to the faulting, so the entire area will be either we constructed any dam or any building, it will be collapsed. So major faults are always the occurring of in the future scenario, so major earthquakes. So this is about entire civil engineering scenario, we find out to that, so whether it is construction of any type of civil engineering constructions. Thank you.